absurd notion, right? But this is the quality of maths, okay? Actually, most of it's going to be right because I eliminated all the choices for you, okay? The hard part about the maths is the choices. I put the things there, and all you have to do is figure out it works. But you still have to check it works, okay? Does it actually work? Look at some things that you might have implicitly assumed in the argument. The middle thing is a square. Is it actually a square? Well, it has to be in the end for the argument to work, right? But is it a square in a way that you can verify? That's a C as well. So one common argument, right, is to say that's a square because the side lengths are equal. Yes? But a square is not something defined by its side lengths being equal. You know that, right? It could be a rhombus. Okay? So we went through this a few times before, but rhombuses don't have to be squares. Yes? What about the outside shape? Is that more obviously a square? So why is the outside shape a square? So now you're saying it's right angle. So you're saying that now if the side lengths are equal, having right angles makes it a square, right? But how do you know there's even 4 sides? That was just totally out of there, right? It's not even clear that this is not an octagon, yes? Did I piece the triangles so that these are all straight? Does that make sense? You might think that's silly because, well, obviously you can piece them when it's straight, yeah? But it's not the case because I can piece that one as straight, yes? And then I can get here and piece this one as straight, yes? And then I can piece that one as straight, yeah? But once I got that one, I can't control that anymore. It has to be either straight or it's not. It's determined by the other 3 placements. Does that make sense? So actually, it's not immediate that the outside shape is a square. Make sense? So this is kind of diligence required to understand mathematics. So in school, sometimes people think school is easy because you're listening to it, you've assumed it's true, and the person does something, and then you agree with them, yeah? But sometimes the higher skill level in maths is to not understand something which is not understandable, yes? Is to not be like, oh wait, why is that a square, you know? So that requires some imagination as well, okay? So you can see it's a mistake to assume it's a square because it has the same sides. But that mistake would make it easier for you to understand this theorem, so at least psychologically, right? Make sense? So then you would move on, and you say, I understood Pythagoras' theorem. And then any time it comes up, you could use this false reasoning to establish other things. But you don't always have the luxury that the things are true. Okay, one day you're going to have to use the reasoning to establish something you don't actually know is true beforehand, right? And then what you're going to do is establish something that's false with flawed reasoning and then believe it's true. This is worse than not knowing, yes? Knowing something for sure, which actually isn't true, right? That's probably the worst possible thing you can get, right? Imagine that, right? Relying on something as if it's 100%. And not only is it not 100% right, it's actually 100% wrong, yes? Because it can only be wrong or right when it comes to logic. Okay. But since I've removed all the choices, we can actually verify, right? So sometimes once you come up with the ideas, it's actually really easy to fix them, yeah? It's just how you understand it depends on your level of maturity and imagination. So it's not the case that someone who understands this, or at least thinks they understand this, is the person who has the greater maths ability. Does that make sense? Sometimes the person who doesn't understand this who has the greater maths ability, right? And then so it comes in levels, yeah? So at first it's like, oh, I understand it because I couldn't think of the problems associated with, and then it's like, oh, I don't understand it because I can't think of the problems associated with it. And then it's like, oh, but I do understand it because I can think of the problems associated with it, but I can fix them. Yeah, and it keep going in those levels. And basically the main difference between really young maths, okay, when you're in year 6 or something, and year 12 maths, is the certainty. That's the quality, yeah? So there are a lot of people that will never get more than 80% on maths tests, okay? And they'll always think it's because they can do 80% of the questions and they can't do 20% of the question, right? But the reality is they're just doing 100% of the questions with 80% accuracy. Does that make sense? The quality is 80% for all the questions. Okay, so this is a place to start. Okay, so let's do this. Let me be specific now. Okay, I'm placing these triangles so that this is straight. Yeah. Okay, and then I'm putting this triangle here so that this is straight. Yeah. So I can obviously do this. Yeah. And then I'm placing this triangle so that that's straight. Yeah. But now I don't know if this is straight or not, right? Okay. Yes.
Well, that sine length is A and B, and those are two right angles, so it has to be straight.
Ah, okay. So you're saying that if this is a right angle, yeah, then this will have to be straight. Is that what you're saying? Yeah, good. So this is going to actually follow, okay? So we have two things to verify, okay? We have to verify whether this is straight or not, yeah? And we have to verify whether this is actually a square or not, yeah? Yes.
You could use coordinate function, I think. So the incline of the bottom C is B over A, and the incline of the top C is also B over A. So.
Oh yeah, certainly, but like yeah, let's try to keep it simple, yeah. Try to keep it simple. So some of us don't know what coordinate geometry is. Is that right? Yes. Okay. Anyway, for example, let's keep it very simple. So I have this angle here, right? You see that this adds up to this angle here to be 90 degrees. Yes? This angle here is the same as that angle, and this angle here is the same as this angle. Yes? You understand what I'm saying? So this and this add up to 90 degrees, right? Because it's a straight line, it has to add up to 180 degrees. So therefore, this is 90 degrees. Make sense? Okay, so another thing is if you're kind of getting it, so we want to be active with the learning, not too passive, yeah? So it's like, oh, that's neat. Don't wait for the next one, because the same argument shows those two are 90, right? Make sense? So try to maybe that's curiosity, okay? So that's a 90, 90, 90, yeah? Okay, which actually means this has to be 90, right? But the reason it's 90 is not the same reason anymore, right? Make sense? What's the reason this could be 90? So this is a little bit of an assumption, but I'm assuming you know that the angle sum of a triangle is 180 degrees. The angle sum of a quadrilateral is 360 degrees. And you can actually break up a quadrilateral into two triangles to prove it only depends on the triangle assumption, yeah? So this is 90 because it has to add up to 360. Yeah? Make sense? And if this is 90, then as Ryan said, these three angles now add up to 180, right? Yes? Then now this is a straight line as well, right? So then we've gotten everything we actually claimed that we got, right? It actually is a square because it actually does have four straight sides, yeah? The middle thing is a square because it does have right angles and not just equal sides. And then this proof is now correct. Make sense? So this is the culture that I'm telling you, okay? So maths is one of those kind of cool things because like even if your teacher doesn't tell you this kind of stuff, sometimes you can figure that out yourself, right? But if you have no idea, you might just get fooled for your whole life, okay? So this is a very important place to begin for us.